This is the review for Unit 3. Number 1 says find the 115th term of the series. It should be sequence below. So if we need to find the 115th term, I'm going to need to write the explicit equation of the sequence. So if you find the pattern, this one is adding 5 every time. And that's true for the whole thing. It adds 5. And so explicit, we can write the first number. And then it's adding 5. And then it's x. This is adding, so I know I don't have an exponent. It's just multiplying x. And because I used the first number is 2, I minus 1. If I had used a 7 here, I would minus 2. And so from here, you just take one of these explicit and you put in 115 for x, and you end up with 572 after you plug in 115. That's the answer. So the next one, same thing. So find out the pattern. This is adding 4 every time. So we're going to have fx equals 3 plus 4. We're going to plug in 115 minus 3 is the first number, so minus 1. And if you actually subtract the 1 and multiply it by 4 and add 3, you get 459. As the 115th term, that would be the number. Find the common constant difference for the arithmetic sequences below. That just means find out what it's going by. If I know that it is 3, I'm going from a 90 to a 77. I know there's got to be something with 3 in it. But if you're unsure and you don't know what it's going by, you can always take the second number. And in this case, the pattern is not geometric. It's definitely arithmetic because it even says it is. Then you would take the second one and you would subtract the first one if you didn't know what it was going by. Or you could just guess and check. And in this case, this is just adding 13 every time. So the constant difference is just 13. On this one, again, you could do the same thing. You could take negative 14 and subtract a negative 18. And you'll know that it is adding 4 every time. Number 3, write an explicit and recursive formula for the following. Hector wants to get his grades up. He starts studying 15 minutes on the first day and he adds 5 minutes. So I know I'm going to write explicit and recursive for arithmetic because this is adding. Add 5. So the first day I have 15. It is adding 5 every day. And I would put x take away 1. Recursive, remember we have fx minus 1. And what is it doing every day? It's adding 5. So here's the previous day. What do I do to the previous day? I add 5. So that's explicit and recursive. Costco decides he's going to save pennies. He starts by saving 15 pennies the first day, and he's going to double the amount of pennies he has from the previous day. So, explicit, we know we're talking about doubling is mathematically multiplying by 2. So this is fx. The first day is 15. I'm multiplying by 2, and therefore I have to have an exponent of x minus 1. Recursive, fx, I can put multiplying by 2 in the front, or I could put it at the end. So your yellow card, though, has the 2 in front, and then just fx minus 1. So you're taking the previous day and multiplying by 2. Okay, 3 again, because 3 continues. So the pattern here, if you notice it goes, so just look at 42 to 7, and then you're getting fractions. This is dividing, and if you got 42 to 7, that's dividing by 6. So if you check it, 7 over 6 is the same as 7 divides 6. So it is dividing 6 every time, which is the same as multiplying by 1 over 6. And this is what we're going to use when we write explicit and recursive. Also, one thing about the test is that when you have this problem, the answers will not have an x minus 1. So that's the tricky part about this question. And so if you go backwards 1 so that you can get the 0 term, so maybe it would help to write out a table. We know the first term is 42, we know the second term is 7, and we know the third is 7 over 6. And I could keep going, the fourth is 7 over 36. So if I want the 0 term, because on the test, again, it's not going to have a minus 1, and it actually just has minus nothing. So we know it has the 0 term. So if we go backwards and we do 42 multiply 6, so we can go backwards, we're going to get 252 here, because we take 252 and divide it by 6, and we'll get 42. So when we write out our explicit, we would have 252, sorry, fx, oh, okay. I'm sorry, the computer did something funny. So fx equals 252, and the pattern is dividing by 1/6, but we know that's the same as multiplying by 1 over 6. And then it's to the exponent of just x this time. We're not going to have anything minus because it actually used the 0 number. So that is what the answers will look like on the test. Again, it's not the same. It's not going to be the same sequence, but you can follow the same method. And then recursive fx, it's multiplying 1/6, and then fx minus 1 for the previous term. D, I would make a table, and I would plug in 0, 1, 2, 3, so you can get an idea. So this, if you plug in 0 here, negative 4 times 0 is 0, plus 2 more is 2. If you plug in a 1, 1 times negative 4 is negative 4, plus 2 is negative 2. And if you keep going with that, the pattern is actually minusing 4, because there is this minus 4 here that's multiplying by x. So that is subtracting 4 every time. And from here, the explicit form is actually already done for you. This is explicit, but you could also write it as, if you wanted to use the first term, you could write negative 2, fx equals negative 2. And then it is subtracting 4 every time, and then x minus 1. Recursive, because if we actually do go ahead and distribute here and combine like terms, we do end up with what we had originally. And then from there, recursive, we just write fx equals fx minus 1. And we know the pattern is subtracting 4, so we put subtract 4. Write the next two terms in the geometric sequence. Again, here, it's definitely dividing. The numbers are getting really small really fast. And if you don't know what it's dividing, you can always do 252, the second one, and divide it by the first. This is geometric, and we know it's geometric, so in this case, to find out what it's going by, we can use division to tell us. And in this case, it's a decimal. So if you if you change it to a fraction, this is going to be multiplying by. Okay, so you do get a decimal. You could also figure out that this was dividing by -6. That is what it's doing here. This is dividing -6 because it goes from negative to positive to negative. So it's dividing -6, which is the same as multiplying -1/6. Same thing. So dividing -6 is the same as multiplying -1/6. And it says find the next two terms. So if I keep going, the next number will be a 7, and the number after that will be a -7/6 as a fraction. Next one, again, this is geometric. It tells us in the problem. So if I take the second and divide it by the first, or you could just guess and check. This one's a little tougher to guess and check because you end up that it's multiplying 0.75, which if you think about money, that's 3/4 of a dollar, so that's the same as multiplying 3/4. And if you keep going for the next two numbers, you'd have 59.4, and I believe I rounded these numbers, and 569.5. So just multiply again by 0.75 or 3/4, and then do the same thing one more time. Label each scenario as arithmetic or geometric. A teacher starts with $30,000. Each year he gets 500. He gets 500. That's adding 500 every year. That's arithmetic or arithmetic because most of you like to say it that way. Mr. Heavyweight is on a diet. He loses 4 pounds every week. Losing 4 is subtracting. Again, that is arithmetic. Next one. Dr. I am Loco has a sick patient. Her white blood cell count doubles. Doubles is mathematically multiplying by 2, so that is geometric. Tom has 12,000 pieces of candy, and he has 90% left every day. That would be the same as taking 12,000 and multiplying by 0.90 or 90%, multiplying it. Anytime you have a percent, this will be geometric every single time. Percents are geometric, it's going to multiply. A family has 4 children. When they grow up, each of them has 2 children, and then each of them has 2 children. So if you have 1, 2, 3, 4, then they all have 2, 2, 2, 2. So now you have 8. And then each of those 8 have 2, 2, 2, 2, 2, 2, 2, 2. And this is doubling. It's multiplying by 2. So if you have people having children and then they're having the same number of kids and same number of kids, this is geometric. Kim has 64 Skittles and eats half. Half. She's taking half or multiplying by 1/2 every day. Or we could put to the x minus 1 would be, and that's geometric. No, you didn't have to write the equation. You just had to put geometric. Bob Vonnet, Voyage, Bon Voyage, has 500 in his bank account. He adds 30, adds 30, arithmetic. Aluminum has 1,000 and he earns 5%. 5%, again, percentage is going to be geometric. Doesn't matter what it's doing. If it's a percent, it's going to be multiplying. I'm going to stop the video there and continue on another one.